A 1.2 kilogram brick is dropped from a height of 2.3 meters into a nail that penetrates into a piece of wood by 1.6 centimeters. How fast is the brick traveling before it hits the nail? Estimate the average force experienced by the nail during the impact. Okay, so we have a potential energy problem. So we'll always draw a little diagram to explain whenever you read a problem. So here's our brick. It starts falling. It hits a nail. We're told that it drops from a height of 2.3 meters. The mass of the brick is equal to 1.2 kilograms. And so we have to find the velocity V final before it impacts the brick. So top, so let's call it the potential energy at top. Let's call it E top. So let's call it E top. It's got potential energy, which is going to be mgh plus, it has zero kinetic energy, so it's got 1/2 m0 squared. And E bottom, let's call it BOT, is equal to, it's got no potential energy, so it's mg times 0 plus 1/2 mv squared. This is what we're trying to find. So this is mgh. Conservation of energy says that the potential energy on top is equal to the bottom energy, so this is 1/2 mv squared. So the first question is, okay, how fast is the brick traveling? So E top must be equal to E bottom. So mgh is equal to 1/2 mv squared. Notice we can cross out the masses, multiply by 2 on this side and square root, so I get V is equal to square root of 2gh. So square root of 2h means that we have 2 times 9.8 times a height of 2.3 meters. Let's bring out our calculator. So 2.2 multiplied by 2.3 multiplied by 9.8 equals yx to the 0.5, and we get 6.7 meters per second. So this is the speed that it's traveling just before it impacts. Notice the height of the nail I didn't include because I assume the nail is very small and it's below less than 10 centimeters of this. So precision is 0.3 meters or 0.01, 0.05 meters. So it's just, what is that? 5 centimeters. So the errors don't count. It doesn't matter. 6.7 meters per second. Okay, so we're told that this impact causes the nail to drop by 1.6 centimeters. So we know that the work done, the energy of the impact, must be equal to the force that the nail pushes on the brick to slow it down. So that's going to be F times the displacement, D. The force is what we're looking for. We're told that the energy of the system, right, is mgh. That's the energy that it initially had in the system, the brick. So the force is equal to, I'm circling the symbol that we need to find. So this is F is equal to mgh over D. So in this case it happens to be 1.2 kilograms times 9.8 meters per second squared. Height is 2.3 meters over a displacement of 1.6 centimeters, but they're not standard units, so we have to convert it into standard units, which is meters. So I'll actually take out the meters. So let's plug it into the calculator. 1.2 multiplied by 9.8 multiplied by 2.3 divided by 1.6 exponent to the 2 negative. So I get 160.90 joules, which rounds up to 1.7 times 10 to the 3, I'm sorry, newtons. 1.7 times 10 to the 3 newtons. So standard units. So